Okay, so I figure since we already started with question number 1 and 2 when we were doing our translating from math to English, or from English to math, I should say, might as well finish it off. So we already created our equation, right, which was, let's see, we said it wasn't this one. So it must be this one right here, right? We said it was this one right here, 2x plus 5. So let's see if we can get that by going through the table and then graphing it and see if all of our representations actually coincide, which they should. All right, so if I take these numbers, I like to start with the positive ones because they're easier to multiply. So if I take 2, and that is my number, so I'm thinking of 2. Okay, got it. All right, and I take 2 times that. So let's see what I get. 2 times 2 is 4. And then I increase that by 5, I will get 9. All right, so if I show my work, let's see, I did 2 times 2 plus 5 equals 9, right? Okay, let's try 1. 1 times 2 is 2, plus 5 is 7. All right, 0 times 2, that's 0, plus 5, 5. Okay, here's one of the reasons I like to start with the positive numbers, because by that point, I already see my pattern. I could continue. I could do -1 times, I'm sorry, I wrote down 0 here. I should have put 2. Of course, right? I could do -1 times 2 plus 5, but I see a pattern. I am, in fact, always, if you read it this way, I'm always adding 2 every time. If you read it this way, you're always subtracting 2 every time. So I could just subtract 2 again from 5 and get 3. Subtract 2 here and get 1. All right, let's just try my work real quick. Let's make sure that's work. -2 times 2 is 4 plus 5. Do we get 1? Hey, we do, in fact. So here are my points. I can see my pattern. In my table, my pattern is every time my x goes up by 1, right? Every time my x increases by 1, my y increases by 2. So we call that the constant rate of change. It's constant because it's always adding 2 every single time you add 2. It's a rate because it's actually 2 divided by 1, right? And it's change because it's telling you how it changes from one x and y to the next x and y. All right, so that's the constant rate of change, or as you like it, the constant rate of change. I'll sometimes refer to it as the croc in class because I think that sounds pretty cool. All right, so my croc is 2, or 2 over 1. Okay. My other number I'm really interested in is what's called the initial value, and that is what is the value of y when you choose your x is 0. And it should be in your table. If it's not in your table, I always tell you, go ahead and make it in your table. If 0 is not in your table, make a 0 in your table. It is in our table, though. It's right here. There's your 0. So my initial value is right here, 5. Y equals 5. See that? Okay, let's talk about graphing it. There's a couple of ways of graphing it now. I could graph from my table. I could plot my points. That's probably the easiest way. I'm at point -2, 1. That'd be start on my origin, go left 2 and up 1, put a dot. Okay, now try it again with -1, 3. So start on my origin. Go -1, up 3. 1, 2, 3, put a dot. Again, I apologize for the low quality of the printing job here. It's not the camera, it's the printer. And so on and so forth until I have my points drawn from my table. All right, now some of you guys, you just connected your dots. I guess maybe that's one of the other teachers taught you to do. That's not really your line, though. A line goes on forever. This is not a line. This is a little line segment. So since on the STAR test you do have, well, let's see, you don't really have a straight edge, but you do have a piece of paper you can use. I just say, just connect your dots, right? Make it go all the way across your paper. Don't be lazy. Just go ahead and connect them, okay? So there is my graph. And it's pretty good. It's not exactly right, but it's really, really close. I like it. Okay. Yeah. My equation now I can get my equation. And also I like to circle not only your initial value in your table, but also circle the initial value in your graph. So in the graph, we don't just call it initial value, we call it the y-intercept. It's the number, it's the place at which your line we just drew intersects with the y-axis, which again is this middle line. Okay, so the point where that middle line meets my line is right here. So I'm going to make it really big. I'm going to circle it. That is the most important point on your graph. Now these two things, I said this was the crock, right? Constant rate of change was 2. Got that from my table. My initial value was 5. Got that from my table and from my graph. Oh, by the way, you can also see your crock in your graph, right? To get from any point to the next point, you have to go right 1. You have to increase your x by 1, right? To get from here to here, don't you have to drive 1 block east? Well, that's that +1 right here. To get from here to here, you have to drive north. You have to drive up 2 blocks, right? You drive east 1, up 2. So there's that ratio right there, right? Actually, they usually say it the opposite way. You go up 2 blocks over 1, up 2 over 1, up 2 over 1. Okay? Up 2 over 1. Okay? And now that I'm almost done. I got my crock, got my IV. Now if I just put an x in the middle of them, an x plus and a y equals in the front, that's my equation. Y equals 2 over 1x plus 5. And sure enough, that's what I had up here. 2x plus 5 equals y. 2x plus 5 equals y. So there's a couple different ways of doing it. You can work from the verbal to the equation. You can work from the verbal to the table. You can work from the table to the graph. You can work from the graph. I mean, all 4 of these ways you can go back and forth. I could give you this equation. You could put into words. You could say, okay, y equals 2x plus 5. That's one way of writing it. You could say, think of a number, multiply by 2, add 5, get a second number. You could say, draw a line, start at your y-intercept of 5, and then make it go up 2 over 1 and put another dot, and that'll give you a line. Okay, so all 4 of these representations, your words, your equation, your table, and your graph, all mean the same thing. They're all exactly the same. They're just different ways of saying it. Okay, just like the number 5, right? I could represent the number 5 in different ways. I could represent the number 5 this way, right? I can represent the number 5 this way. I can represent the number 5 this way. You know, your Roman numerals, right? I could represent the number 5. I'm kind of out of ways of doing it. Maybe in binary, if you'd like binary, right? That's way too confusing. Binary, who says that? Well, you could. All right, there's lots of different ways of representing the number 5. They're all exactly the same.
Good afternoon.
We'll stop there.